Hello, everyone. It is my pleasure to join you today at the 2021 American Rainwater Catchment Systems Association Annual Conference and Expo. I'm Tom Smith with the American Society of Civil Engineers. ASCE is a nonprofit organization created in 1852 to advance the public health, safety, and welfare by connecting and educating civil engineers across the globe. With 150,000 members in 177 countries, we publish books, journals, and standards, conduct continuing education programs, and we have 9 technical institutes and hundreds of sections, branches, and student chapters worldwide. It is our mission to lead the profession in creating infrastructure that is safe, sustainable, and resilient so that it can protect the public and ensure our quality of life. Due to the COVID-19 pandemic, we certainly learned a lot over the past year. It is also clear there are many challenges ahead, and much more needs to be done to mitigate them. With these challenges, however, come great opportunities to do things differently in the future, to innovate, to rethink, to replan, to rebuild with safe, resilient, sustainable infrastructure that will serve not only current generations, but also generations long into the future. I think it's useful to start off by evaluating some of the challenges we face right now, both for our country and worldwide, particularly as we move forward following last month's Conference of the Parties, or COP26 in Glasgow. On a global scale, the world population of 7.8 billion people continues to grow at more than 80 million people per year, while population centers are shifting as we are increasingly becoming an urban society where most of the growth in the population resides in cities. This creates challenges for our communities and the profession. At the same time, we're experiencing increasingly severe weather events, and the Intergovernmental Panel on Climate Change recently issued its State of Climate Science report, agreed to by 195 countries, noting humanity's unequivocal role in driving climate change. The report finds that the Earth is expected to reach the critical threshold of 1.5 degrees Celsius warming due to climate change within the next 20 years, with implications including more extreme heat, heavier and more variable rainfall, snow and permafrost loss, ice sheet melt in Antarctica and other areas, ocean acidification, sea level rise, and more. Hurricane Ida made landfall in Louisiana in August, exactly 16 years to the day after Hurricane Katrina made landfall, causing widespread damage across the northeastern United States. Hurricane Ida led to more than 60 fatalities and billions of dollars in damages. As bad as this was, damages in New Orleans could have been far worse if not for the hurricane protection system constructed by the Corps of Engineers following the painful lessons of Hurricane Katrina, which claimed more than 1,800 lives and ranked as the costliest natural disaster in U.S. history. While the $14.5 billion investment for the hurricane storm damage risk reduction system following Katrina was very significant, history shows that reacting to such natural disasters is more costly, as evident from the National Oceanic and Atmospheric Administration's damage estimates of $170 billion for Katrina, $74 billion for Sandy, $131 billion for Harvey, and $52 billion for Hurricane Irma. Indeed, the National Institute of Building Science's own studies have shown and taught us that mitigation measures save up to $13 per $1 invested. In addition to Ida, which also further brought to light again the needs and vulnerabilities of our energy infrastructure, we've watched other recent significant weather events causing flooding in countries like China and Germany, as well as locations around the United States, where we've also suffered from wildfires and droughts, which in the United States led the government to declare a water shortage at Lake Mead, triggering major water cuts in western states. Other challenges also loom, as we're of course still in the midst of a global pandemic that has taken over 4 million lives worldwide, and the world continues to experience other disasters, including Haiti recently suffering from another catastrophic earthquake, losing more than 2,000 lives and thousands more injured. In each of these challenges I mentioned, I would submit to you that our infrastructure plays a critical role, and we must ensure that our physical infrastructure is smart, sustainable, resilient, and safe. And this requires a team effort of engineers, owners, operators, contractors, policymakers, and many others. As engineers, we are problem solvers, and as we look to the future, we have some global challenges ahead. Looking further over the horizon, the United Nations highlights our challenges with Sustainable Development Goals to be achieved by 2020. Confirmed by over 190 countries, the list includes poverty, hunger, clean water, clean energy, infrastructure, reduced inequality, sustainable cities, climate. Each of these sustainable development goals are critical for humanity and for our planet. And I would again submit that each of these goals require smart, innovative, sustainable, resilient, and safe infrastructure as part of the solution. To reach these goals and address our global challenges, we need to ensure that everyone has opportunity and access to clean water, clean air, energy, sanitation, shelter, transportation, broadband, communications, education, occupation, and security. And each of these infrastructure needs are critical to addressing poverty, inequality, and sustainability. Moving to the United States and the challenges faced at home, this is the 2021 Report Card on America's Infrastructure, which ASCE issues every 4 years as a comprehensive assessment of the nation's major infrastructure categories. Using a simple, familiar A to F school report card format, the report card examines current infrastructure conditions and needs, assigning grades and making recommendations to raise them. For the first time ever this year, America's cumulative GPA is a C-. This GPA has improved slightly from a D+ in 2017, indicating we've made progress around the margins in some infrastructure areas. However, 11 categories are still in the D range. Those include much of the infrastructure Americans interact most closely with every day, like roads, transit, dams, and levees. Often these categories are where we failed to make investments needed to maintain the assets that were built 50, 75, or more years ago. One of those 11 categories was stormwater. Stormwater earned a D in 2021, and this was the first time we graded this category. Stormwater utilities are on the rise, but there are many challenges to better managing stormwater across the country. Impervious surfaces in cities and suburbs are expanding, exacerbating urban flooding, which results in $9 billion in damages annually. Many of the country's legacy stormwater systems are struggling with the high cost of retrofits needed to accommodate climate change. Federal funding, though up in recent years, averages about $250 million annually, which leaves a growing annual funding gap of $8 billion just to comply with current regulations. I want to underscore the impacts of chronic underinvestment in our infrastructure. As Congress debates the largest investment and now has passed in our water, transit, road, and bridge systems in a generation, action is urgently needed. Failing to close this infrastructure investment gap brings serious consequences. According to ASC's latest economic study, Failure to Act, if we do not address the infrastructure investment gap, our economy will lose $10 trillion in GDP, nearly half the annual US GDP in 2019. More than $23 trillion in total output, primarily business sales, and more than 3 million jobs in 2039. Additionally, we believe there will also be more than $3,300 in families' annual disposable income lost each year from 2020 to 2039. That's the hidden tax that we all pay by failing to invest in our nation's infrastructure. So now that we've talked about all these challenges and implications, what do we do to protect the economy, address the investment gap, and provide a more sustainable and resilient future? The solution requires action at many levels. ASC's report card defines key solutions centered on leadership, investment, sustainability, and resilience. There is, of course, a very positive development on the leadership and investment front, with last month's passage of the historic bipartisan infrastructure bill, known as the Infrastructure Investment and Jobs Act. The legislation includes $1 trillion in spending, of which $550 billion is new federal money for infrastructure. It also includes $110 billion for roads, bridges, and major projects, $66 billion for passenger and freight rail, $65 billion for broadband internet, $46 billion for resilience to help states and cities prepare for droughts, wildfires, climate change, and more, $39 billion for public transit, and $17 billion for ports and waterways. The legislation has certain pay-fors. The negotiators agreed to repurpose over $250 billion from prior pandemic aid. That includes $50 billion from expanded employment benefits to fund the plan. Additionally, the agreement proposes to save $50 billion by delaying Medicare's rebate rule, raise $30 billion from tax information reporting requirements on cryptocurrency, and collect $50 billion in fraudulently claimed unemployment benefits throughout the pandemic. This is a generational investment in the nation's infrastructure, following decades of advocacy and education. and we believe it will have a monumental impact on the economy, public safety, global competitiveness, and each American's well-being. Passage of this 5-year, $1.2 trillion bill proves once again that the country can lead with sustainable, resilient, and safe infrastructure. Of course, this is really just the beginning and not the end, and there will be a great deal of work with federal agencies, state and local governments, and the private sector as we move on to the implementation phase. As infrastructure investment is moving forward with a national vision and partner, ASC is focused on ensuring that public and private infrastructure investments are forward-thinking. Last year, the ASC Board of Direction approved a comprehensive rewrite of the ASC Code of Ethics, the most extensive change to our ethical code in more than 45 years. Looking forward with this new Code of Ethics, we're working to advance its goal that all infrastructure is safe, sustainable, and resilient, and that civil engineers develop and apply innovative, state-of-the-art practices and technologies. ASC's new Code of Ethics has a stronger focus on sustainability, including responsibilities to adhere to principles of sustainable development and mitigate adverse societal, environmental, and economic effects, using resources wisely while minimizing resource depletion. Among other initiatives, ASC has also formed the Institute for Sustainable Infrastructure over 10 years ago. That's a joint program with the American Public Works Association and the American Council of Engineering Companies, as well as the Harvard Zofnass Sustainability Program, that has developed the Envision rating system. This is a tool designed to recognize and encourage sustainable infrastructure development and can be used for planning, designing, and rating projects. ASC also helped to create the International Coalition for Sustainable Infrastructure, which includes a partnership with the Global Covenant of Mayors for Climate and Energy. Next week, we're hosting the International Conference on Sustainable Infrastructure, a virtual event focused on sustainable and resilient infrastructure at the local, community, and global level. An advocate for sustainable infrastructure, Prince Albert II of Monaco, will also be speaking at the event. We issued a COP26 climate change communique last month, and on the 4th anniversary of Hurricane Harvey, Houston Mayor Turner voiced his support for engineering climate-resilient infrastructure and the Declaration for Climate Resilient and Sustainable Infrastructure, which was developed by ASC and the Stimson Center as a call for action to mitigate climate disasters that destroy essential infrastructure such as hurricane, epic floods, wildfires, and droughts. In December of 2019, ASC Structural Engineering Institute endorsed the vision of the SE 2050 Challenge to transform the practice of structural engineering in a way that is holistic, firm-wide, project-based, and data-driven. By prioritizing the reduction of embodied carbon through the use of less or less impactful structural materials, participating firms can more easily work toward net zero embodied carbon structural systems by 2050. ASC is also working on a new performance-based lifecycle sustainable infrastructure standard. Finally, with the National Oceanic and Atmospheric Administration reporting 20 disasters last year that cost $1 billion or more, the most on record, engineers are keenly aware of the importance of resilient infrastructure. Investment in climate-resilient infrastructure is critically and increasingly important. That's why we're collaborating with NOAA and the University of Maryland Center for Technology and Systems Management to focus on advancing the use of climate science within engineering practice for the design and construction of climate-resilient infrastructure, especially during the development and updating of ASCE codes and standards. We have many other resilience initiatives underway, including the continued study of infrastructure performance in the case of extreme situations or disasters, and a 2022 workshop to examine changing environmental conditions and the environmental loads used in standards. Our goal is to increase the pace of climate adaptation and reduce design, construction, and maintenance costs, as well as the cost of climate-related natural disasters. Also on the topic of sustainable infrastructure, I wanted to mention another project ASC completed last year. That's a sustainable parking lot at our Reston, Virginia headquarters. This slide shows ASC headquarters location relative to the Chesapeake Bay. You can see water flows from the ASC parking lot to Colvin Run, to Difficult Run, to the Potomac River, to the Chesapeake Bay, ultimately into the Atlantic Ocean. The Chesapeake Bay's entire watershed is about 64,000 square miles and is under a TMDL, a total maximum daily load, for phosphorus, nitrogen, and sediment. These three key pollutants are causing algae blooms and lower dissolved oxygens in the bay, which has destroyed a huge amount of marine life that lives there. Here you can see our ASC headquarters located on the Dulles Toll Road. The most notable detail here is the vast amount of impervious cover, rooftops, parking lots, roadways, non-point source pollution from all these surfaces, most of which were built before there were stormwater management requirements, is causing the degradation of our local and regional waterways. Here's some project background. I would note that it was important to show civil engineers around the world, as well as our community, what can be done when you're in a building that's getting to a point in its life where it has to begin renovations and restorations, and how you do that in a more environmentally sensitive way. There were many plan iterations, but the final plan involved losing parking spaces in a few areas, creating more green areas for bioretention, adding permeable pavements, and paving the remainder of the parking lot with rubberized asphalt. 24 parking spots with permeable interlocking concrete pavers were added in front of the ASC office building, consistent with ASC Standard 68-18 on permeable interlocking concrete pavements. These are interlocking concrete pavers and are a fantastic BMP product with very low maintenance. The water goes in through the rocks and into the subgrade, flowing into a stone base and subbase layers that serve as a reservoir that can store and infiltrate flows from a 100-year storm event. Filtration, settlement, and infiltration are occurring during the process with a minimum of 50% removal of phosphorus and often 80 or 90% removal. Around the corner from this area, 11 parking spots were created using Stormcrete precast porous concrete panels made by Porous Technologies. The panels are manufactured with a concrete mix that has a uniform coarse aggregate gradation and includes minimal fine aggregates. These materials are used in a proprietary mix that results in a large volume of interconnected voids, 15 to 20% voids. The voids allow stormwater to pass through the panels into the soils below, and from there into a biofiltration structure called Focal Point, made by ACF Environmental. One issue with porous pavement has been compliance with the Americans with Disabilities Act, or handicap accessibility. Stormcrete has a product that makes porous tactile warning panels, which are required by ADA and which you can see here. The Focal Point bioretention system uses high flow media to treat the runoff faster and in a smaller footprint than traditional systems. The system treats for common urban runoff pollutants, including total suspended solids, phosphorus, and nitrogen, while also providing reductions in oils, grease, and bacteria. After that treatment, the runoff flows through an outlet pipe to the existing storm drain. The domed overflow helps maintain larger storm events, and the filter insert collects any mulch or debris from the surrounding planting areas. The Rain Guardian turret is a pre-treatment device that collects any leaves or trash that might come off the upstream pavement area, protecting the biofilter behind it. The other bioretention systems, the Filterra tree box, was located just upstream from an existing drain inlet. This 13 by 7 foot filtering unit was shoehorned into a spot in the sidewalk near the building's front steps between finished pavement and existing utilities behind the curb and next to the building. There's an opening in the curb that brings water from the surface into the Filterra tree box, and then there's a biofiltration medium that processes the stormwater at a faster rate. Runoff enters the unit not through the pavers, but through an existing curb inlet. Stormwater flows through a specially designed filter media mixture contained in a landscaped concrete container called the Filterra tree box. The filter media captures and immobilizes pollutants, which are then decomposed, volatilized, and incorporated into the biomass of the Filterra system's micro and macrofauna and flora. The system aids in the removal of 50% of phosphorus materials. The remainder of the parking lot, some 105,750 square feet, 105,750 square feet, was repaved with 1,200 tons of asphalt made with recycled tires supplied by Asphalt Plus. The pavement for the project included 11 pounds of Elastico brand chemically engineered crumb rubber per ton of asphalt, which equates to roughly 722 scrap tires that were recycled and kept from landfills. Engineered crumb rubber is ideal for pavement, not just for parking lots, but for standard roads and highways as well, for a number of reasons, including to stiffen the mix, reduce rutting potential, to make the pavement more strain tolerant, which reduces the rate of cracking, and to slow or stop the movement of cracks that do occur. Additionally, the pavement has been shown to last longer, require less maintenance, and use less material than standard pavement, equating to a lower life cycle cost. The parking area also includes a new vegetated courtyard, which features pavers engraved with the names of ASC members, AC Foundation donors, and others. Without these donations, as well as the in-kind and material donations made toward the project, the cost would have been $700,000. With those donations, the actual outlay that the foundation made for the services and materials was reduced to $440,000. We also added informational signage on the site, and I hope you all can stop by sometime for a tour. In addition to our efforts to walk the talk on sustainability and civil engineering, we also want to be thought leaders in looking at the future. And we wanted to look far enough into the future to ensure we didn't just extrapolate a view of the future that was not much different than the present. We started with research in future trends and a classic future scenario analysis. That has been completed. And now we're creating a computer model by which we visualize those results. To help us understand the impact of that, the Future World Vision project creates an immersive environment. We want everyone to really imagine 5 communities of the world 50 years in the future, all designed to be radically different and provocative. So we're creating virtual worlds from a very macro city wide view right down to a neighborhood view so the users can really begin to understand how they will live. And engineers can explore, collaborate, and consider how they can make the future a better place to live. There are a large number of and a variety of global changes coming our way, and they are hugely interconnected. We've experienced lots of change in the past, but it's rare to see this many vectors of change impacting us in a relatively short time period. Everything from technology, such as automation, autonomy, and the Internet of Things, to alternate energy, climate change, demographic changes, smart infrastructure, and new materials, all of which will impact the built environment. The Future World Vision is creating multidimensional ways to virtually examine this phenomena. These dimensions allow us to examine the energy construct, the transportation systems, the water and wastewater elements, and so forth. That is how an engineer can provocate about how useful today's designs are for future problems, and more importantly, things that we do now that in fact are not good solutions 50 years from now. That allows us to take the right steps toward life cycle resilience with both the present and the future properly considered. These are the 5 city worlds that we selected. They will emerge and evolve in the approximate timeline, and the ones further out on the timeline are obviously more speculative than the ones that emerge sooner. This chart shows just a few of the ingredients that help us to create these future communities, in addition to speculation based on our research. We also model innovations from a variety of disciplines and a few relatively unpredictable disruptions. Future World Vision is not attempting to predict the future. It is a platform by which we ask ourselves questions about the future, so we are not surprised by those unexpected conditions if they occur, or caught off guard in failing to prepare for them. Our research yielded a few key transformational imperatives that engineers need to embrace in order to design and build the desired future built environment that is plausible in 50 years. Let me point out a few of those. 1, the world is focused on climate change, but changes in demographics and urbanization patterns will also have significant impact. 2, we'll be dealing with a world that is digital in everything, which creates the world of autonomy, AI, the Internet of Things, and so forth. 3, we don't know what technological advances will specifically occur, but we can be sure that there will be things like quantum computing, synthetic biology, and new materials. And lastly, the 4th industrial revolution represents the nexus of all these trends, which will force us to understand system dynamics. We believe the Future World Vision project can have a great impact on our industry and our profession. We think it has the potential to help us make progress toward these transformational imperatives. We want you to be among our network of those that create the future built environment, including the radically different future built environment that's possible. As we develop all our future virtual cities, we have 2 overarching themes that infuse every element of the city. The digital and virtual worlds will join the analog and physical worlds. The merging of those worlds will continue unabated despite some hurdles yet to be cleared. Those who design and build the digital infrastructure ecosystem And those who design and build a physical infrastructure will need to understand the intersection of what we do. And the principles of circular economies will be universal. So we will explore everything from resilience to sustainability, to consumption, to regenerative reuse, to social equity. Let's watch a video made in late 2020 describing the Future World Vision project, and in particular, the megacity prototype at the current stage of development.
If you don't make a plan or make a goal and have a vision, then you just react your way into the future. And that's not what we want to do as civil engineers. We want to lead into the future.
How we do our jobs as civil engineers, maybe as systems engineers, will be different in the future.
What are the different cities we see evolving, and how can we really get an understanding of those cities? How can we immerse ourselves in those cities today?
What are the different social infrastructures, physical infrastructures that can be created in which we can all come together and thrive?
What's really important about looking at this through a world-building lens is that it is designed to look forward and then thread back into the present. The further out you look, the more it changes our view of the present.
What can a megacity grow toward so that it's serving a better purpose? You start looking at individual buildings then, because you can typically shape a building. And can you connect several buildings together?
The buildings might form coalitions and interact with the utility, and the utility will interact with the providers of energy all around. That becomes a transactive energy system, and the buildings can play an active role.
Every building in the future should be capturing sunlight and rainwater, and every building should be recycling its own waste.
Ideally, the life cycle of infrastructure is one that is continuous, or perhaps reused in the future without going back and re-emitting all that carbon to do the same thing over again. That's the way we've built over the last century, and we simply cannot do it anymore.
Buildings are not unlike a human body. They have bones and skin. They consume energy and regulate temperature and generate waste. What if architects use genetic tools from synthetic biology to encode the architecture of buildings right into the DNA of organisms?
You might have 175 drones coming in at 11:45 a.m. delivering lunch. Where do they land? How much space are between them? What are the specifications?
It just has to be designed in a way that people can interact, and making sure that you're encouraging paths of travel that are spontaneous.
We're at just the right point in time to get together and build basically the aerial equivalent of what we did in this country with the national interstate highway system, and no longer be restricted to 2 dimensions.
So how do you get the public involved in civil engineering, in the process of civil engineering?
One of the best ways that we can make sure that all voices are heard and included is to start with the people who are doing the planning and developing and see what their teams look like.
How can you ensure social equity and social justice and get input from the community for the projects that we're working on?
We are very conscious about the demographic, the diversity of the community and the society, and make sure that we don't leave anybody behind.
Creating these multi-use spaces is one way of doing that, of bringing people together. And once they're in the same shared space, there is more opportunity for connection, there's more opportunity for shared experience, there's more opportunity for civil dialogue.
The best solutions on Earth, they come with diversity of thought. What I love most about the Future World Vision Project is that we can think about it together. We can have this dialogue.
Users will encounter one another and have conversations across disciplines that will begin to feed back and bring new information into the system.
We're trying to build a world and trying to build a machine that is creating absolute engagement of the user and of the engineer in their own future.
Oh my goodness. This 4th industrial revolution, married to the fundamentals of concrete, glass, and steel, is this incredible toolbox for society.
As you can see, in this future world of tomorrow, cross-disciplinary thinking will be critical. So I thank you for your time and look forward to finding ways for ASCE, the American Rainwater Catchment Systems Association, and the essential members and professions we represent to modernize, futurize, and reimagine our infrastructure and quality of life. Thank you.